So today we're going to talk about exponential situations. And the nice part about these exponential situations is they're going to behave a lot like how the graphing behaved and a lot how the table patterns behaved. So the first thing that we have to realize with this is the type of formula most times we're going to write, where this is our start value and this is our growth / decay. So that's how it really breaks up. In this first problem, when we're kind of going through this, it says how much money would you have if you deposited $5,000 in an account that earned 8% interest after, and then we have the years 10, 20, and 30. So the first thing that we really need to do with this is we need to go, okay, what do we start with? So our start amount is $5,000. Then how much do we grow by? A lot of people want to say we grow by 8%. And that is not quite true. And the reason you know that is if you took 5,000 and times it by 8%, which is 0.08, you would get 400. You'd be like, oh, that's not increasing, that's decreasing. That's decreasing to 400. Well, that 400 is the additional money you made. So we find out that way, like 8% of something, that's what you do, that's the additional money that you made. But like if you put $5,000 in an account and after like 1 year of timesing that, they gave you $400, you'd be like, I need my original money back. Like, yes, I made $400 extra. So because we made $400 extra, this isn't really 8%. It's 108%. So when they say an 8% increase, they mean we get 108%. So that's how much money that we get. Because we get the 1 stands for our original amount, and the 8% stands for our new amount. So we have 108%. And then we just have to figure it out for that many years. So if we wanted to do that once, that'd be 1 year or 10 times. So this is our equation, and we're just going to kind of fill it in. So for this 10 years, it'd be 5,000 times 1.08 to the 10th. This would be 5,000 times 1.08 to the 20th. And this would be 5,000 times 1.08 to the 30th. Let's figure out what those numbers are. They're probably pretty big. So 5,000 times, and on all this stuff, you should use your calculator. Like, don't do this by hand. Like, you don't really want to times 0.08 10 times. So this one's about, if we round this, about 10,794. For your thing today, I think you're going to round it to the nearest cent. This is 22,000 or 23,000, my bad. 304. And this last one would be 5,000 times 1.08 to the 30th. So that's 50,000. So if you had $5,000 and you put it into an account that earned 8% interest, if you just waited 30 years, you would have quite a bit of money. That is quite a bit of time. So as you can see, like, if you have money, if you could put it in an account, like, you're going to make money in the long run. Okay, let's do the same thing with a car. So this was a growth situation because we increased by 8%. So this was a growth situation. Let's see with this next situation. It says, I have a car that cost me $15,000. And cars do not increase in value, they depreciate, meaning they lose value. So again, if we have our nifty formula from before, A is our start value, so we start with $15,000. B is our growth/decay. Now in this, it says we depreciate by 15%. Now again, like we could try our original thing where we go, okay, we have 15,000 times that by 0.15 because that's 15%. And oh, that did decrease. But that's a lot. Like that decreased from 15,000 to 2,000 in a single year. Like I hope my car doesn't lose that much value that quickly. And that doesn't really make sense. Like we lost so much of our value. So this is the way you want to think about decreasing in 15%. You always start out with 100%. Like that's how much you always have is 100%. Then we decrease by 15%. Well, how do you think you decrease from 100%? Oh, I would subtract 15%. And that would leave me with 85%. So my car value after every single year will be 85%, or 0.85. So this is the general formula that I can use to find for each year marker. And so we would just write that in, 15 to 0.85 to the 5th, 15, 0.85 to the 10th, and 15, 0.85 to the 20th. Now, instead of actually doing this every single time on my calculator, let's just do the first one so we can kind of get a feel for, is this more realistic? So let's see after 1 year. Oh, after 1 year, okay, that looks a little bit more realistic. My car would be worth about $13,000. I'm only losing $2,000 in value after a single year. Let's see after 5 years. After 5 years, my car is only worth about $7,000, and it would keep going from there. And that's probably it probably decreases a little bit too quickly compared to like an actual car value, but it's a little bit closer. I guess if you have a certain type of car that already had mileage on it, or you drove it more, it would probably decrease much quicker than some other cars. So that's the basic idea from what we're going to do today. We're going to use this formula. This y equals ABX formula. A will always be our start value. B is going to be our growth or decrease. If the thing grows, you want to start with 100% and add your 8%. If the thing decreases, you want to start with your 100% and then subtract. Okay. So that's the kind of basic idea for these things.